So for 4.5, this is a continuation where we're going to be using some of our log properties, and we're going to look at exponential and logarithmic equations. We're going to solve exponential and log equations using inverse properties and the properties of logs, okay, which we just did in 4.4. So when you are solving exponential equations, there are two different ways to do this, okay? Keep in mind that an exponential equation has an equation that contains one or more expressions that have a variable as an exponent. So the exponent is in the variable. Okay, so we have never solved for an exponent in the for a variable that's in the exponent before. So this will be something new. So in order to solve it, we either have to rewrite the equation with the same base, which is what we'll do without a calculator, or take the log of both sides. So a lot of the ones that we did in 4.4, did you guys see how those were really nice? We could rewrite them with the same base. Okay, but we did have one in 4.4 that we couldn't write with the same base. Remember when we had like log base 5 of 8? And we couldn't rewrite like 5 to the x equals 8? See how we couldn't solve that quickly? Okay, we're going to learn how to do that with the calculator. Okay? All right, now we're going to focus on the ones without a calculator and rewriting with the same base. Okay, so we want to write these equations with the same base because if the bases are equal, what did we talk about today? What do we know? The bases are equal. What else has to be equal? The exponents. Okay, the exponents have to be equal. And again, that's because you can't have like 2 to the 5th power is equal to 2 to the 6th. Those aren't the same thing, right? It's just like you can't have 16 equal to 32. Those are not equal. Okay, the other option that we're going to do that later is taking the log of both sides. Okay, we'll do that later on. And the reason why we would have to take the log to solve an exponential equation is because exponential functions and log functions are what? Yes, they are inverses. Okay, exponential functions and logarithmic functions are inverses, which means those operations undo each other or cancel out. Okay, some of this language should sound familiar of things that we already talked about. Okay, so the inverse operations are going to undo each other or cancel out. Okay, I'm feeling pretty confident that with example 1, when you have to solve and check for part A, okay, if I tell you that you have to rewrite those with the same bases, do you think you could rewrite 9 and 27 with the same base? Yeah? Okay, yeah, what would your base be? Yeah, 3. Good. Okay, so let's rewrite that. So you are going to solve and check. There is going to become a time when the checking is mandatory. Now is not that time. But I am going to show you how to do some checking to make sure. But some of these, I would have you check it with a calculator. And I'll tell you when you have to watch out. So if you can, for these, you rewrite with the same base if possible. Some of them are possible in this section, some of them are not possible. Okay, so you guys already told me 9 and 27, you can rewrite those with the base of what? 3. So 9 would be 3 squared, and then I'm going to keep this as the exponent. 27 would be 3 cubed, and I'm going to leave this as x minus 3. So once you have the same base, you're going to set the exponents equal. Okay? When you set the exponents equal, you do want to remember a property, because see how you have a power to a power? If you have a power to a power, what do you do with the exponents? Yeah, you multiply. Okay, so power to a power means multiply your exponents. Okay, so when I multiply these, this is going to be 2 times 8 minus x. This is going to be 3 times x minus 3. And I want to write it like this so I remember to do what? What am I going to have to do with these? I'm going to have to distribute. Okay? So 2 times 8, 2 times negative x will be 16 minus 2x. Distribute on this side. This will be 3x minus 9. Okay, and then can you guys solve that for x, please? So get all your x's on one side. Get all your numbers on the other side. And it really doesn't matter what side you move them to. A lot of times we try to keep the x's positive, but again, it does not matter. Either way, you will end up with what for x? 5. Okay, so x equals 5, that is your final answer. Okay, when you are checking these, your check is just going to be you plugging this back in. So this would be 9 to the power of 8 minus 5 equals 27 to the power of 5 minus 3. And something like this, the 9 cubed equals 27 squared. I would let you check that with your calculator. Okay? So 9 cubed would be 729. That would equal 729. If both sides are equal, you did it correctly. Okay? Again, a check is not something mandatory that you have to do for all of these. I just wanted to show you what the setup would be for those. Okay, now for these, 1/5 and 1/25, what base should we rewrite them with? That? Yeah, let's rewrite it as 5. Because 5 to what power is 1/5? 5 to the negative 1 is 2x. And then 5 to what power is 1/25? So 5 to the negative 2. Okay, now make sure when you rewrite these are equivalent. You should not be changing the value of this. 3 squared is 9. I did not change that is 9. 3 cubed is 27. I did not change that value of 27. 5 to the negative 1 is 1/5, so I did not change that. Okay, and then 5 to the negative 2 is 1/25, so I did not change that. And they have to have the same base. Okay, could you rewrite 1/25 with a base of 1/5? 1/5 to what power is 1/25? 1/5 squared. So you could do that as well. Sometimes there's more than one way to write it. Okay, and then now we're going to set the exponents equal. And then if you want, you can multiply this at this step. What's negative 1 times 2x? Negative 2x. And then here, just remember that you got to distribute to both. So this would be negative 6x plus 12. And then we're just going to solve that for x. Okay, so we'll get 4x equals 12. Divide both sides by 4. And then your x value is 3. Okay, so do you guys think that you can do part C? So you have 2 to the power of 4x plus 1 and 1 over 32. So when you have a fraction with a 1 on top, look at the bottom number, okay? First of all, 2 can't be rewritten as anything. It just has to say 2. But can you write 32 as a power of 2? Yeah, 2 to what power is 32? So 2 to the 5th is 32, so this would be 2 to the negative 5th, would be 1 over 32. And then once you have your bases equal, what's your next step? Exponents are equal. Okay, so once you have the same base, now you're just going to rewrite with the exponents. So 4x plus 1 equals negative 5. Okay, so you set the exponents equal and solve for x. So we're going to subtract 1 from both sides. 4x equals negative 6. And then you just have to reduce if you have a fraction. So this would be negative 3 over 2.